welcome to Science Access. In today's video, we'll be dealing with the expansion of solid and liquid part 2. Please, if you know you are new to this channel, kindly like and subscribe to get notification anytime we post a new video. To get a better understanding of this expansion of liquid and solid part 2, please go back to our previous video where I talked about linear expansivity and I also do some calculation on that. In today's video, we'll be taking the area expansivity and the volume expansivity. So let's start with the area expansivity. Area expansivity is the increase in area per degree rise in temperature. The area expansivity is denoted by the symbol beta, and it has the formula change in area over area change in temperature, where the change in area represents is still the same thing as A2 minus A1, then A1, while change in temperature is the theta2 minus theta1, where A2 represents the final area, the A1 represents the initial area, A1 represents the initial area, while theta2 represents the temperature at A2, while theta1 represents temperature at A1. Area is still the same thing as length times breadth. We all know that one. So let's take some examples under area expansivity. Example 1. The length of a side of a box at 25 degrees Celsius is 5 centimeters. What would be the area of the box at 55 degrees Celsius, given the linear expansivity to be 6 times 10 raised to power minus 5? Now, like I said before in the previous video, anytime we want to calculate a question under expansivity, we bring out the parameters first. So from our question, what are our parameters? They said a length of side of a side of a box at 25 degrees Celsius. So that 25 degrees Celsius will be our first theta, which will have theta1 at 25 degrees Celsius. Then is 5 centimeters. Our 5 centimeters is our length. Which will have 5 centimeters. But in the question, they said we should calculate area. So what do? We said 5 centimeters raised to power 2. That is 5 times 5, which you have 25 centimeters square. Since it's area, they asked us to find. So what's our next parameter? What is the area of the box at 55 degrees Celsius? We take our 55 degrees Celsius to be our theta2, which we have here. Then our linear expansivity, 6 times 10 raised to power minus 5. Remember, our linear expansivity is 2 times, our area expansivity is equal to 2 times the linear expansivity. So since our linear expansivity is given to be 6 times 10 raised to power minus 5, so we multiply it by 2, which we have here. It gives us 12 times 10 raised to power minus 5. So they say we should calculate the area of the box. So it's the area we're looking for. So from our formula, we know that our area is equal to A2 minus A1 over A1, theta2 minus theta1. So, but we are looking for the area of the box. So what do? We cross multiply. This is equal to this times this. So that's how we got the formula here. A2 minus A1 equals to beta times A1 bracket theta2 minus theta1. So A2. Okay, this is just how we derive the formula by cross multiplying. We just took this one, A2 minus A1 equal to this times this. So that's how we derive our formula. So bringing our parameters to solve the question, A2 is equal to, what is our A1 in the parameter? A1 is 25 centimeters square, which we have here. Then our 1 come down. What is our beta? Our beta is 12 times 10 raised to power minus 5, which we have here. What is our theta2? Our theta2 is 55 degrees Celsius, which we have here. Our theta1 is 25 degrees Celsius, which we have here. So what do? We solve for the bracket. 25 come down. 1 plus 12 times 10 raised to power minus 5. 55 minus 25, we have 30. So we solve what is in the brackets first. We go for the multiplication first. 12 times 10 raised to power minus 5 times 30, we have 0.0036. Then if you add 1 plus that 1 plus 0.0036, we have 1.0036. Then multiply by this 25 that is outside. That is 25 times 1.0036. We have our area to be 25.09 centimeter. So let's take our number 2 question. A box of size 20 centimeters square is heated from 25 degrees Celsius to 50 degrees Celsius. If the linear expansivity of the metal is 2.4 times 10 raised to power minus 5, calculate the increase in area. Like I said before, we have to bring out our parameters first. So from the question, what are our parameters? A box of size 20 centimeter, we know that um, our 20 centimeter is our area. So our first area. So we bring the area here, which is our also known as our initial area. So it's heated from 25 degrees Celsius. We take our 25 degrees Celsius to be our first theta, which we have here, 25 degrees Celsius. Then our 50 degrees Celsius, we take it to be our second theta, which we have here. Then they said if the linear expansivity of the metal is 2.4 times 10 raised to power minus 5. So this is our linear expansivity. Linear expansivity. Remember I said to get our area expansivity from linear, we have to multiply our linear expansivity by 2. So which we have here, our area expansivity is equal to 2 times our linear expansivity, which that means 2 times 2.4 times 10 raised to power minus 5, which we have here, is equal to 4.8 times 10 raised to power minus 5. Then they said calculate the increase in area. So that's what we are looking for. So from our formula, we know that our area expansivity is equals to change in area over area in bracket theta 2 minus theta 1. But they said we should look for change in area. So what do? We cross multiply. When we cross multiply, we have change in area equal to beta times area in brackets theta 2 minus theta 1. That's how we got the formula here. Then we take our parameters to solve the question. What's our beta? In the question, in our parameter, our beta is 4.8 times 10 raised to power minus 5, which we have here. What's our area? Our first area is 20 centimeters square. We have 20 here. What is our theta 2? Change in temperature. We have our theta 2, 50 degrees Celsius, which we have here, minus our theta 1. What is our theta 1? 25 degrees Celsius, which we have here. Then we solve the brackets for 50 minus 25, we have 25 degrees Celsius. So we have 4.8 times 10 raised to power minus 5 times 20 in brackets 25 degrees Celsius, or you can say times 25 degrees Celsius. So when you multiply 4.8 times 10 times 4.8 times 10 raised to power minus 5 times 20 times 25, we have our change in area to be our 0.024 centimeter square. Now let's move to the number 3 question. If a solid of 20 centimeters square and 45 centimeters square is heated 10 degrees Celsius and 20 degrees Celsius respectively, calculate its area expansivity. This one is just straightforward, just by applying the formula and you get your answer. But before then, we have to bring out our parameters first. So what are our parameters from the question? They said if a solid of 20 centimeters, so we take our 20 centimeters to be our first area, then and 45 centimeters square, we take our 45 centimeters square to be our second area, then it's heated 10 degrees Celsius. We take our 10 degrees Celsius to be our first theta, then and 20 degrees Celsius, we take our 20 degrees Celsius to be our second theta. Then they say we should calculate for area expansivity. So we know that our formula for area expansivity is A2 minus A1. Okay. So we know that our formula for area expansivity is A2 minus A1 over A1 in bracket theta 2 minus theta 1. So what is our area from our parameter? Our A2 is 45 centimeter, which you have here. Then minus our A1. Our A1 is 20 centimeters square. We have it here. Then our A1 20 centimeters square. Our theta 2 is our theta 2 is 20 degrees Celsius, which you have here. Then minus our theta 1. Our theta 1 is 10 degrees Celsius, which we have here. So 45 minus 20, we have 25, which we have here, over 20 comes down. 20 minus 10, we have 10. So equals to 25. 20 times 10, 200. So our 25 over 200 is equal to 0.125. Now taking 0.125 is to standard form, we have 1.25 times 10 raised to power minus 1 in Kelvin. So this is our final answer for calculating the area expansivity to this question. Now let's move to number 4 question. An area of 8 centimeters square is heated from 20 degrees Celsius to 45 degrees Celsius. If the linear expansivity of the cube is 2.6 times 10 raised to power minus 5, calculate the increase in area. Now, like I said before we calculate any question under expansion or expansivity, we have to bring out the parameters. Now, from our question, what is our let's bring out our parameters. They said an area of 8 centimeter square. We'll take that one as our initial length. I'm sorry, initial area, which we have here. Is heated from 20 degrees Celsius to 45 degrees Celsius. We take that as our temperature, our initial temperature and final temperature, which we have here. Then if the linear expansivity of the cube is 2.6 times 10 raised to the power minus 5. So our linear expansivity, but they said we should calculate increase in area. So our linear expansivity will be 2 times, I'm sorry, our area expansivity will be 2 times our linear expansivity, which you have here, 2 times our linear expansivity. So we have 2.6 times 10 raised to the power minus 5 times 2, which is 5.2 times 10 raised to the power minus 5. Then they say we should calculate the increase in area, which is what we are looking for here. Now, we know our formula for area expansivity is change in area over initial area, then change in temperature. So, but they say we should calculate the increase in area. So what do? We cross multiply. When we cross multiply, we say angle area is equals to beta times what we have here. That's how we got this formula here of finding our increase in area. So what's our beta? In our parameter, our beta is 5.2 times 10 raised to the power minus 5, which we have here. Then our initial area, which is A1, we have it as 8 centimeter, so which we have here. Then our theta 2, our theta 2 is 45 degrees Celsius, which we have here. Then our theta 1 is 20 degrees Celsius, which we have here. Now let's solve. 5.2 times 10 raised to the power minus 5, which we have here, times 8. Then we solve for the bracket. 45 minus 20, we have 45. Now if we multiply all this together, which is 5.2 times 10 raised to the power minus 5 times 8 times 25, we have our change in area to be 0.0104. You can also be asked to change this to maybe 2 decimal points. Once you change to 2 decimal points, that means your answer will be 0.01 in 2 decimal points. So that is the answer for this question. Now we'll move to number 5. Number 5 says if a 10 centimeter square experiences 0.020 centimeter square change in area when heated from a temperature of 10 degrees Celsius to 20 degrees Celsius, calculate its area expansivity. Now bring out the parameters first. Now, what is the parameters from the question? They said if a 10 centimeter square, that 10 centimeter square will be our initial area, experiencing 0.020 centimeter square change in area. So our change in area will be 0.020, which you have here. Our change in area as 0.020 centimeter square. Then, when heated from a temperature of 10 degrees Celsius to 20 degrees Celsius, that will be our theta 1 and theta 2, which you have here, 10 degrees Celsius and 20 degrees Celsius. Then they say we should calculate the area expansivity. We just use the formula for area expansivity, which we have as change in area over initial area, theta 2 minus theta 1, which is change in temperature. So what is our change in area? Our change in area from our parameter is 0.020, which we have up here. Then our A1, which is our initial area, is 10 centimeter square, which we have here. Then our theta 2 is 20 degrees Celsius, which we have here. Then our theta 1 is 10 degrees Celsius, which we have here. So we solve 0.020, we bring it down. Then this 10, we bring it down. 20 minus 10 is also 20 minus 10 is 10. So equal to 0.020, which we have here. 10 times 10, 100. So 0.020 divided by 100 is 2 times 10 raised to power minus 2 2 times 10 raised to power minus 4 per Kelvin. So that is the answer for this question. So we move to volume expansivity. Remember I said we have 3 basic expansion in solid, which are the linear expansivity, linear expansion or expansivity. We have the area expansion and we have the volume expansion. So we are doing volume now. So what's volume expansivity? It's defined as the increase in volume per degree rise in temperature. Now, our formula, volume expansivity is denoted by the symbol gamma. So our volume expansivity is equal to V2 minus V1, which is also the same thing as our change in volume, over V1 in bracket theta 2 minus theta 1, where V2 denotes final volume, V1 denotes our initial volume, V1 initial volume, while theta 2 is the temperature at V2, our theta 1 is temperature at V1. So we can also find the formula for calculating change in volume. All we have to do here is just to cross multiply. So when we cross multiply, we have, remember our V2 minus V1 is also the same thing as our change in volume. So our change in volume will be equal to gamma times V1 in bracket theta 2 minus theta 1. So this is the formula for finding change in volume. If you are given any question on that change in volume, so this formula will use. Now let's move to some calculations under volume expansivity. Now, question number 1. The length of a side of a metallic cubic at 20 degrees Celsius is 4 centimeters. What will be the volume of the cubic at 120 degrees Celsius, given the linear expansivity as 4 times 10 raised to power minus 4? Remember I said anytime we are looking for the solution to any problem in expansivity, we have to figure out the parameters first. So let's look at our parameters from our question. The length of a side of a metallic cubic at 20 degrees Celsius. So we take our 20 degrees Celsius as our initial temperature, which is our theta 1, which we have here. Then it's 4 centimeters. 4 centimeters. Remember, they asked us what will be the volume. So this 4 centimeters is already in linear. So we have to take it to our volume, which we say 4 centimeters raised to power 3. 4 raised to power 3 is 64. So we have our initial volume to be 64 centimeter cube. Then they say what will be the volume of the cubic at 120 degrees Celsius. So we take 120 degrees Celsius as our final temperature, which is theta 2, which you have here, 120 degrees Celsius. So they said we should what? Calculate the volume of the cubic. So we're looking for the volume here now, the volume of the cubic. Now, from our formula, we know that our cubic is for finding volume. We have our gamma equals to V2 minus V1 over V1 theta 2 minus theta 1. Now, but they said we should calculate the volume of the cubic. That is our V2. We should calculate the volume of the cubic. So what we do here, we cross multiply. When we cross multiply, we have V2 minus V1 equal to our gamma times V1 in bracket theta 2 minus theta 1. So we take minus V1 to the other side, it becomes plus V1. So we have V2 equal to V1 plus our gamma times V1 in bracket theta 2 minus theta 1. So we continue. V2 equal to V1 in bracket 1 plus our gamma theta 2 minus theta 1. So this is how we just derive the formula. Okay, note, I got this one by, we have V1 here, we have two, they are common, so I use them as one, which we have here, then plus our gamma. We can also use, if you don't really understand, you can also use this formula to solve your question. It's also the same thing. So that's how we got our formula here. V2 equals to V1 in brackets 1 plus gamma angle theta. So we use our parameters to solve. V2 is equal to what? V1. What's our V1? Our V1 is 64, which we have here. Then 1 plus our gamma. What's our gamma? Our gamma is 12 times 10 raised to power minus 4, which we have here, times our change in temperature. Our change in temperature, remember our change in temperature is final temperature minus initial temperature, which is our theta 2 minus theta 1. So what is our theta 2? Our theta 2 is 120 and our theta 1 is 20. So we say 120 minus 20 as our change in temperature, which you have here, 120 minus 20. So we solve 64. 64 come down. Then 1 plus 12 times 10 raised to power minus 4, which is here, times 120 minus 20, we have 100. Then V2 is equal to 64. Then we solve for the bracket. We have 1 plus 12 times 10 raised to power minus 4 times 100, which is 1.12 when you solve it. So we now said final velocity, volume, our final volume is equal to 64 times 1.12. So our V2, when you multiply 64 times 1.12, we get 71.68 centimeter cube. Now let's move to our number 2 question. A solid of metal cube of size 10 centimeter is heated from 20 degrees Celsius to 70 degrees Celsius. If the linear expansivity of the metal is 1.2 times 10 raised to power minus 5 Kelvin, calculate the increase in volume. We bring out our parameters first. So in the question, what's our parameters? So they said is solid of metal cube of size 10 centimeter. So we take our 10 centimeter to be our initial volume. Remember, they said 10 centimeter. We have to take that to volume. So by taking it to volume, we say 10 raised to power 3. So which we have 10 raised to power 3 is 1000 centimeter cube, which we have here as our initial volume. Then they say it's heated from 20 degrees Celsius to 70 degrees Celsius. So we take our 20 degrees Celsius to be our theta 1 and 70 degrees Celsius to be our theta 2, which we have here, here, and here. So they said if the linear expansivity of the metal is 1.2 times 10 raised to power minus 5, so our linear expansivity is 1.2 times 10 raised to power minus 5. But they said we should calculate the increase in volume. Remember, they gave us linear expansivity. So we have to convert this linear expansivity to volume before we can calculate for the increase in volume. So by calculating this linear expansivity to volume, we say 1.2 times 10 raised to power minus 5 times 3, which is 3 times linear expansivity. That's how we get our volume. So if you say 3 times 1.2 times 10 raised to power minus 5, it's going to give you 3.6 times 10 raised to power minus 5 in our volume expansivity, which we have here. Now I've gotten our parameters. Now let's solve. What's the formula for volume expansivity? We have gamma equals to change in volume over initial volume in brackets theta 2 minus theta 1. So, but they say we should calculate the increase in volume. So what do we do here? We cross multiply. When we cross multiply, we say change in volume is equal to gamma times V1 in bracket theta 2 minus theta 1. That's how we got the formula here. So what's our gamma? Oh shit. So what's our gamma? Our gamma is 3.6 times 10 raised to power minus 5, which we have here, times what's our V1, our initial volume. Our initial volume is 1000 centimeter cube, which we have here. Then our theta 2, what's our theta 2? Our theta 2 is 70 degrees Celsius, which we have here, minus what's our theta 1? Our theta 1 is 20 degrees Celsius, which we have here. So we continue. 3.6 times 10 raised to power minus 5 times 1000, we solve for brackets, 70 minus 20, we have 50. So we have 50 here. So 3.6 times 10 raised to power minus 5 times 1000 times 50 is equal to 1.8 centimeter cube. So we have our final answer of our increase in volume to be 1.8 centimeter cube.